So this talk is about porting wine to Android, which is the thing I've been working on for several months now. So I'm going to present quickly the goals of the project, which are probably fairly easy to guess. I'm going to show what is working today. It should also be pretty quick because that's not a whole lot. And then explain some of the technical challenges and explain what remains to be done, which will be a lot longer. There's a pretty big list of things to do. So the first goal is obviously to run Windows binaries on Intel Android devices. Windows binaries being built for Intel CPUs, so we need an Intel CPU in the device. That's basically exactly what we do on Linux and Mac. The other possibility is to use Wine to port Windows source code to create native Android binaries with packages. This, of course, opens the possibility to also support ARM devices. The tricky part is you need the source code for the entire application, which most vendors don't have the source for the whole applications. Most Windows apps always use some kind of third-party DLL, and then you get into the CPU compatibility problem again. And then the last goal is, of course, to run the Windows binaries on ARM devices, which is an interesting challenge. But of course, since most Android devices are using ARM, then this is what's going to make the project really useful. So what is working today? We've added support for the Bionic C library. So Android is using a Linux kernel, so that part is obviously working already fine. But the C library is different, so we had to port Wine to the C library. It's mostly adding configure checks and replacing functions that are missing and stuff like that. So that was fairly easy. That's all in the Wine tree now. So if you get the Wine source, you can build for Intel Android or ARM Android simply with the configure online. You have to install the Android NDK, of course, and then you can build an Android version of Wine. Of course, what you get if you do this is that it's a version of Wine that lets you run command line applications, which is not all that interesting. And also, if you try this configure, you will get a huge list of warnings about missing libraries, because there is a ton of libraries, well, a number of libraries that Wine is using. We try to keep it down to a minimum, but we still need a number of external dependencies. And these are, of course, not provided with the Android NDK. So if you actually want a version of Wine that is useful, you then need to cross-compile a number of other libraries, which most of the time is also just a matter of doing configure --host and build the library. But some of them are more tricky. This is, of course, not really a Wine issue, so not something we can really do anything about. But it's, I mean, if you want to build a full package, that's one of the problems we have. You need to build a lot more than just Wine. And the last thing that is working today is a basic graphics driver that I've put together that is not in the Wine tree at the moment. It's basically on my disk, and that's all. And this driver is using Wine in desktop mode, so that's the mode where everything is inside a single window, and you have the window management, so Windows decoration and stuff like that. So this is not supposed to be the final driver. I'm hoping to do a driver that integrates much better with the Android OS, that doesn't look too much like Windows. But at least it lets you see that the applications are working and make sure that it behaves reasonably. So at this point, I'm going to try to show it. So this is Android for Intel running in VirtualBox on the Mac. I don't have an actual Intel device here, so it's still native Intel CPU. It is a bit slow, but that's because of VirtualBox. The Android itself is a bit slow. Why? Cool. So as you can see, you get Wine application on your Android task manager. That's one of the things we are trying to address, is that you don't really want Wine here, you want your applications. So if you install Office, you would want Word and Excel icons on the Android task manager. But right now, all you get is Wine, and then start Wine, and hopefully get some. Yes. So I've made it start a command prompt. So this is the standard Wine desktop that you get on Linux if you enable desktop mode. And the icons are the desktop launchers. So if you put link files in the desktop directory, you get the icons. It's the same as on Linux. And so it works just fine. I can start PowerPoint. Hopefully there's no feedback when you click the icons, so it's a bit tricky to know if it really started or not. Actually, no. Yes, it works. So this is PowerPoint on Android. Yes. So I'm cheating a bit here because I have an actual hardware keyboard and hardware mouse, which makes everything easier to use. This one, an actual tablet, it can get kind of tricky to click on the icons, and I mean you have to use your finger, and your finger is probably big like that. In this case, PowerPoint is actually pretty good at scaling up the interface. So I tell PowerPoint that it's on a high DPI screen and it scales everything up. So you can actually use it with your finger. It's more or less usable. One problem you have is, for instance, if you try to exit PowerPoint, the exit option is somewhere here. So because it's scaled up, then there's no way it can fit everything on the screen. So that's one of the things we need to address, is to have some kind of panning or zooming, unzooming of the interface, so that you can use a desktop application on a small device. But apart from that, you can do much anything. What we have up there is the software keyboard icon. So if you click that, you get the Android software keyboard, which of course is eating up the screen. I also had some hacks that try to pop up the keyboard when the application is showing the blinking arret automatically, but that doesn't quite work at the moment. So there is this icon that you can use to show and hide the software keyboard. And for some reason the keyboard doesn't work right, but that's not Wine's fault, that's Android. It should go all the way here. And if I click on P, it actually presses I, because I don't know why it's scaled this way. But it happens the same way in native Android apps, so it's not my fault. And then you can hide the keyboard again to see what you're doing. Okay, well, that's it for PowerPoint. And then again, as you see, this is desktop mode, so you get Windows decoration, you get Win95 style graphics. I mean, it's purely Windows, it's not very integrated. So again, the goal would be to make this be an Android dialog, like a native Android, as far as possible. And that's basically all that's working. Try to switch tasks. Again, what you see if you go to the task manager is you see just one. What you would really prefer is to have PowerPoint, Word, and so on in the Android task manager and be able to switch applications this way. But for the moment, you have to go back to Wine, and then inside Wine you switch to a different application. Right, and if you quit, then it's, I think it's, no, it's still on. Sometimes you quit and it doesn't come back, but this time it did, so that's good. So, going back. This is what is working. So some of the problems I've had to achieve that, and I will have to achieve a lot more. First is Java, of course. Android applications are written in Java. And there are actually fairly good mechanisms in Java to call native code, and from native code to call back into Java. So this is actually fairly well thought out. One of the issues with Android specifically is that most of the Android APIs, especially window management and so on, can only be called on the main Java thread. So you can call Java methods from the native app, but it doesn't really help because you're not on the right thread. So you still need some messaging mechanism to make Java calls. Which leads us to the issue of the process architecture, because if you're running in Java, of course, you need a Java process with a Java virtual machine, and that doesn't really suit itself to running Windows binaries, which really want to be in their own separate process. So the next slide will explain more about the process architecture. There is the issue, of course, of the missing libraries. So this is the list of libraries that I've had to cross-compile to be able to run Microsoft Office. It's already a fair bit, and there are more than you need. If you want a full Wine version, there are even more than that. Most of these were actually fairly easy. Samba is probably the worst at cross-compiling. And that Samba 3, Samba 4 is hopeless. Never able to cross-compile. The other issue, of course, is lack of keyboard and mouse. So you don't really see the issue because I had keyboard and mouse. You can use the software Android keyboard, of course, for entering text. That just works. But if you want to run some games, for instance, that want special keys, or that wants to use the keys as control instead of text input, then we need some sort of mechanism for that. Probably a virtual PC keyboard where you can enter more than just text, where you have function keys, where you have that sort of thing. And the mouse, of course, is also the problem that you need a very precise pointer for many Windows apps, especially Windows apps that don't scale up the interface, don't scale up all the buttons, because then you get very small buttons, and we need some way of being able, for instance, to zoom a specific part of the interface, or I was considering maybe when you touch a button, it would zoom up, and then you can touch the actual place that you meant, something like that. So that's all in the air for now. High DPI screens, obviously, that's the main problem. Most tablets have a very high resolution, but a very small screen. So we need a way to pan and zoom.
But you will have that now on the desktop.
Yes, it's getting more common also on the desktop, yes. And there are ways in Windows to use high DPIs, and modern applications handle that correctly, but of course the old ones don't. And PowerPoint was a very good example of an app that's done right, but that's because Microsoft can afford to do that. Many other apps don't. I'll show one later on. So yeah, we need a way to do that, and it's a bit tricky because the zoom, you cannot do a clean zoom like you do when you're using a web browser. When you zoom and it re-renders the web page in a higher resolution. With the Windows app, of course, all we can do is blow up the pixels. So it's not going to look very, very nice, but that's basically the best we can do. As far as OpenGL, there's only OpenGL ES on Android devices, which is, of course, not something we support at the moment. So we need to be able to do direct 3D on top of OpenGL ES, and not just OpenGL. And if we want to run OpenGL games, then we need OpenGL on top of OpenGL ES. So that's an interesting challenge. And of course, at the moment, there's no way at all that we can do OpenGL, because what I'm doing with the desktop mode graphics driver is that it's basically a display surface that I'm copying the bits into from the different applications. So there are actually several copies of the window bits into the desktop, and then from the desktop into Android. And of course, with OpenGL, you cannot copy the bits 3 times across different processes. So at the moment, there is absolutely zero OpenGL support. And I don't know when we'll have it. And then there are a number of restrictions when you want to distribute Android packages. You need to sign the packages, for instance. And that's a problem if we want, like I mentioned, to have the Windows applications on the task manager. Right now you have a wine icon, so that's a wine package. But what you really want is PowerPoint, Word, and so on. And to be able to have that on the task manager, they basically need to be Android packages, which ideally you would, when you install an application, you would generate the package to make it appear on the task manager screen, but you cannot generate the package because it needs to be signed. So there are ways around that, but it's kind of tricky to make it look like a Windows app is actually an Android package. And if you want to distribute the packages, for instance, in the Google Play Store, then there are also size limitations. Packages can be only 50 megs in size. And once you put all of wine in the package, it's basically over 50 megs already. So that's kind of tricky. What you have to do is to create a separate package that you download separately from the main package and install the wine library somewhere else. And I don't know, so for now, I just upload the package to USB, so there's no size limitation. That's going to be addressed. So a little bit about the architecture, how this is all working. So in Android, normally you have a Java process, so this is the main process that's running the Java VM. And you have all the Android Java classes running inside that process. And you don't actually have much control over the process layout in Java. So you cannot, for instance, tell Java, create me a new process. So what I'm doing is the wine activity. So this is a Java class that's basically an activity. An activity is an Android application. The wine activity would load the Windows wine libraries inside the Java process. So in this case, it would be explorer.exe because that's the desktop process. It's the one that's doing all the desktop. Of course, I'm showing Explorer here, but it also loads NTDLL, kernel, user32, and everything. So these get loaded inside the Java process. But when you want to start a new wine process, then you cannot do that from Java because it will all be still inside the same process. So what I do is fork and exec the wine process, which is then a purely Unix process. It has no Java, it's basically a Linux process. And that makes things a bit trickier because from the wine processes you want to display something on the screen. There's no way of doing that because you would have to make Java calls. But you cannot make Java calls from a process that is not inside the Java process. So we actually, at the moment, I have actually everything going to the wine server. And for displaying Windows, I use shared memory. And everything else is using basically Win32 messages and stuff like that, going to the wine server, which is also a separate Unix process. The advantage of doing it this way is that we have plain wine processes here. We control the address space layout. We can use the wine preloader to set up the address space. We can have signal handlers. We can do everything we do on Linux. Basically, it's a standard Linux process. I tried at some point to make every process into a Java process so that we can do Java calls from any one process, but it's very difficult. There is no way you can get control over the Java process. You cannot pass file descriptors. You cannot set environment variables, stuff like that. So this is the architecture I'm setting. So what remains to be done now is, of course, the user driver. So that's basically all the window management, all the things having to do with the clipboard, with mouse and keyboard. It's really a big task. It's at least as big as the Mac driver that we did for the last release. And this was probably, it took a year, basically, to do the Mac driver. So I expect the Android driver is going to take at least as much time. And that's mainly what I'm working on now. We're doing the window management to integrate more into the Android desktop, get rid of the desktop mode, make basically every Windows app into a full screen Android app, use Android pop-ups for the pop-up dialogues and stuff like that. We need, of course, to do Direct3D and OpenGL on top of OpenGLES. That's also a fairly big task. We need sound support. There are sound APIs that are usable from native code on Android. It's based on OpenSL, I think, which is kind of like OpenAL, only different. So, yeah. I have no idea how hard that's going to be, but that's going to be Andrew's problem at some point. May not be that hard. it's not that different from Linux. Then I need to figure out how to make all of this build from the wine tree, which is going to be interesting because there is Java code. And of course I can put the graphics driver in the wine tree, but the graphics driver is not going to do anything useful unless it can call Java. And the Java code needs to be in the wine tree, but you really cannot build Java simply from a makefile. You have all sorts of, all the build infrastructure for Java is in Java, and I don't know how it's all going to be able to be integrated, and how I'm going to make it possible for people to just run make and get an Android package. So that would be interesting. And the last thing we need is to do more integration, like I mentioned, having apps show up in the task manager, having, for instance, MIME type associations. So if you receive a Word document in your Android email client, you can click and it opens in Word on your Android device, things like that. That's also kind of tricky because, once again, many of these things need to be part of the Android package, which is basically you specify at compile time and you build the package and you sign the package and you distribute that. So you cannot, after the fact, tell Android that, yeah, by the way, this package also handles Word document once you install Word. You have to specify that at compile time. So I don't know how that's going to work. And of course, the last thing is the QEMU support, so that we can run Intel binaries on ARM devices. And I've been actually playing with that, and it's working reasonably well. There are some bugs in QEMU, unfortunately, which I was hoping we have QEMU people that we can blame. I don't know.
Not going to step forward
No,
now.
they probably shouldn't.
You should have asked first and then said.
Well, I went to a few talks yesterday trying to find QEMU people without success. Yeah, so the way I'm doing QEMU, actually, okay. Here's the architecture with QEMU. So normally what you do with QEMU is you simply run the whole of wine under QEMU, and then in theory everything works just fine. You get wine x86 and you run that under QEMU and it works. The thing is, on Android you cannot do that because parts of wine are running inside the Java process. And on an ARM device you cannot get an x86 Java VM and run the Java process under QEMU. So what I'm actually doing is that I'm using native ARM binaries for all of the wine parts. So Explorer.exe and of course NTDLL, Win32, kernel 32 and so on are all built for ARM. And so this is all native ARM code, this is all native ARM code, this is all native code. And only at the point where we try to run an x86 binary, then I will launch a QEMU process and run this specific binary inside a QEMU process. So the advantage here is that, of course, you get much better performance because everything apart from the wine binary is running natively. The wine server in particular is running natively, so you get full speed there. All the window management is running natively. You get the full speed here. So basically you have only one small, or not so small, depending on what you run. At this point it's only solitaire because that's the only thing that doesn't trigger QEMU bugs. So it's very small. But it actually runs surprisingly well. When I tried this, I was expecting that it would be totally unusable, and it's actually usable. I'm still hoping we can fix the QEMU bugs and get Microsoft Office working so that we can assess the performance with the real app. But it really looks like we can do something with that. Of course, the drawback with this approach is that because all of these are native binaries, you basically need 2 full versions of wine. You have the ARM version of wine for all these processes, and you have the x86 version of wine for this process. So it makes the package twice as big, which was already a problem with only one version. But it's working, and I actually have a device here that nobody is going to be able to see because it's very small. But I have a screenshot of the device. I still brought the device so you can see I'm not cheating. So I bet nobody sees it. I can launch. It works. And solitaire on an arm. So you can come here after the talk and see that it's for real. And this actually demonstrates also some of the problems we have with the scaling. Because here I'm reporting high DPIs, so all the interface elements that are done by wine are scaled up. But for instance, the score here is done by solitaire and it's not scaled up because solitaire doesn't expect high DPI screens. Or for instance, the icon over there is pretty much unreachable. I mean, if you have to touch that with a finger, there's no way you can click this icon. So that's the sort of issue we have. This is an especially high DPI device. So, the difference is pretty obvious. Actually, you can read the text here because it's blown up. But on the device, it's actually pretty hard to read, even for me at this distance. So. Right. So that's what I'm hoping to do. Once we fix the QEMU bugs, we should be able to basically run everything the exact same way as we did on Intel devices. Of course, there are a number of issues with that. If we go back to the architecture design, because we now have ARM processes and Intel processes running with the same wine server. And the wine server is meant to support that. I need support for multiple architectures, but there are issues, for instance, in the registry. With the Windows registry, you have CPU information. So, do you put ARM CPU information or Intel CPU information in the registry? That's the sort of issues that we need to solve. Basically, to have kind of a transparent view of the registry, depending on which process is querying it, you return the Intel version or the ARM version. Stuff like that.
Well, just like on x86.
Yeah, it's kind of the same mechanisms as 32 and 64 bits. Except there are no Windows mechanism for that, so we need to invent some.
So you can do it better than Microsoft.
Yes, yes. Shouldn't be too hard. So that's it for this presentation. Some question, I'm actually going to ask the first question because I know everybody is going to ask that. Actually, since I did the demo, the initial demo last year, I've been getting mail about once a week from people, when can I get wine for Android? So, well, you have to be a little patient. At the moment, it's basically all on my disk, and it's not really in a state that I can give to someone and have it do something useful for anybody else. I will be trying to release patches as I go. Everything that's not related to the graphics driver has been merged. I'm hoping also to merge the QEMU stuff, because that's relatively straightforward. The graphics driver is going to take a while before it's available. And also at this point, I don't really need anybody to test the code and find problems, because it's not hard to find problems. I can do it myself. So that's all I had. Are there other questions?
So that's not for you, but when do we get that on Linux on ARM then? Because that the Win part would be useful for that.
Sure. That's the idea. I mean, I can merge that part and it can be used on any platform. Yes?
Doesn't Windows RT have a mechanism to run Intel binaries on Windows RT yet?
It does not.
No.
Windows RT is basically that.
Yeah, one thing you could do is to run Windows ARM binaries on ARM devices. But
Well,
of course,
They don't even officially let you run those. They
Exactly.
only let you run the Microsoft ones that ship with it.
yeah, you cannot get ARM binaries to run. And even if you could, I mean, there are like 100 times more Android apps than WinRT apps, so there's probably nothing you need. So that's why the focus is on desktop apps.
And additionally, all the, as far as I know, the WinRT and also Windows Phone APIs are pretty much unsupported in Wine at the moment.
Yes.
You can run a Windows Phone command line application if you happen to build such an exe. That works, but
Actually, there are people that are submitting patches to get those API DLLs into Wine, because they need them on Windows Phone.
yes, that was me.
Oh, okay.
You are many things.
Do you know how to get it fixed?
Yeah, just a small matter of code.
Have you thought about a use case where you use the phone as a desktop device? So you put it somewhere and then you use Bluetooth keyboard and normal monitor, and then run. So like you open your Mine application once you're in the setup.
Sure, you can do that. I mean, if you have a hardware keyboard and mouse and big screen, we'll take advantage of it. So yeah, that would work. I mean, you want both. You don't want to be limited to that case. But yeah, it definitely
Like,
works.
Canonical tries to do this kind of
Yeah,
stuff.
yeah, exactly.
Yeah.
And it's actually the way you most likely want to use it. I mean, you can put PowerPoint on your phone, but
That makes sense.
it's only really usable once you plug your phone into the big screen and the keyboard. But yeah, that would work. Yes.
What kind of memory and storage requirements are there to run Solitaire or Office?
Solitaire is trivial, but yeah, Office is pretty big. Initially, the VirtualBox session I had 256 megs of RAM, and that was not enough for Office. So I had to bump it to 1 gig of RAM in VirtualBox, so that would be pretty much the same on an actual device. But most devices have that kind of memory now.
So, whatever, presentations, PowerPoint as well, was actually running in 1 gig.
Yes. That's a 1 gig VirtualBox. Yeah. And the disk space is actually, again, depends on the application. I mean, Wine is about 50 megs. It's, I don't know, 100 megs once it's extracted. But then if you install Office, it's a couple of gigs. So you need that space on your device.
Yeah, so you could run PowerPoint on a Windows PC with only 1 gig. Run Windows. Yeah.
Maybe not. No. You need space for Windows. We don't need space for Windows. Other questions?
Do you plan also to support iOS?
No. I mean, it's completely different, and could be done in theory, but Apple is never going to let you in the App Store, so nobody is going to be able to get your code. But sure, in theory, someone could do an iOS driver. Yeah.
Do you need a rooted device to run this?
No.
Okay.
I use rooted devices for debugging, but that's a lot easier. But no, at the moment it's a bit tricky because I've not tried to run the installers, so I install basically the app on a PC and then copy the files over. And for that you need root permissions so that you can modify the files inside the application. But ultimately you run the installer on the device and then everything uses the app permissions and you don't need root. Questions?
Is the plan for OpenGL to also do remote procedure calls like you do it for basic Windows at the moment? Or do you see any other option?
No, the plan would be to get access to the OpenGL surface and send the calls directly to that.
Let's say you are on an ARM device and running an x86 binary where you're going to x86 OpenGL binary.
That's harder.
So, but what I basically had in mind is with the command string for D3D,
yeah.
Would it make sense to design it in such a way that what's currently the thread that executes everything could be a separate process? Because we have had remote procedure called
sure.
D3D at some point.
Sure.
So that could be used for D3D stuff.
Well,
yeah, resource updates need some need some better way, but streaming the command data itself is not an issue.
Yeah, but I mean, really, you don't really need to go through the other process except for getting access to the surface. Once you have that, then you can do everything natively, except of course in the x86 case. Questions? Well, thank you very much.